So yeah, if you want to follow along, you can start out by scanning the QR code. My name is Adrian Hill. I'm a PhD student at TU Berlin, more specifically in the machine learning group under Bifold. And today I will tell you what's new with explainable AI in Julia. So at JuliaCon 2022, I presented my package, ExplainableAI.jl, and today I'm happy to announce that this package has grown to an entire ecosystem and organization, and this talk will more or less be an invitation for you to join in this ecosystem. So this morning we already had a talk on trustworthy AI by Patrick. What we are looking at specifically, Yes, great. So what we're looking at specifically are post-hoc local input space explanations of black box models. So what does this mean in simpler terms? What we want to look at is which parts of the inputs into a model are responsible for the model's outputs. And more specifically, we're going to look at classifiers here. So let's start out with a motivating example. We have this image of a castle in front of a busy street. And we start out by loading pre-trained machine learning models. So in this case, using Flux and Metalhead. And once we've loaded this model, we can evaluate it on the input and get a prediction. And in this case, the model correctly returns class 484, which corresponds to the castle in ImageNet. So we got the correct answer. That's a great first step. But if we use such classifiers for more crucial decision-making processes, we might want to know why this class was predicted. So this is where several of these explainable AI methods come in, some of which I've presented last time. So general gradient-based methods are part of ExplainableAI.jl, which is a package that can be used on any differentiable classifier. So it's not only Flux, but also MLJ compatible. And we also have a new package, relevance propagation, .jl, which implements methods which need definitions of usual machine learning model layers. So here we've opted for flux.jl. And in these packages, we have several new methods. For example, support for ResNets and newer transformer architectures in Layerwise relevance propagation. All right, so what does it look like to use these packages? Well, if you've already loaded your pre-trained model, it's quite simple. You import one method package, so in this case, explainable AI, and one visualization package. So here I've opted for vision heatmaps, since I'm dealing with a vision model. And then I create an analyzer. In this case, I've used the gradient analyzer, which basically computes input sensitivity. So just the gradient of my output class with respect to my input image. So not the parameters, but the image. And the API is very simple. I just call analyze on an input and an analyzer, and I get an explanation. And if I then call vision heatmaps heatmap function on this explanation, I get a heatmap. And I don't know if it's very well visible for you, but the magnitude of the gradients is slightly higher in the domain where the castle was located at. And yeah, this is maybe not the most convincing explanation. It's due to a phenomenon called the shattered gradient problem, but that's why people have come up with other methods as well. So I could also just swap out my analyzer. So I've just changed the third line of code. I've swapped the gradient analyzer for gradcam, and then this method will give me a different type of heatmap. All right. What I can then do is use a completely different package for completely different methods. So here I swap out ExplainableAI.jl for relevance propagation, and I can evaluate this method called Layerwise relevance propagation. And here I get different relevance scores. So pixels that have contributed positively towards an explanation are highlighted in red, whereas things that have contributed negatively are highlighted in blue. So that's maybe this street in the lower right corner, and things that didn't have so much influence are left white. Okay, so how does all of this work? Well, basically, methods and visualization packages, both built on a common interface that is defined in XAIBase, so Explainable AI Base. And this defines an interface, an explanation type, which is just a very generic wrapper type to dispatch on. It gives you shared utilities to select outputs of a classifier, and also intermediate features if that's something that the method requires. And yeah, if we then use XAIBase and Flux, we can write a package like relevance propagation. And you are also kindly invited to build on this common interface and add your own custom XAI packages. So we've seen some of these methods. Let's maybe dig a bit deeper into the visualizations and the interface. Vision heatmaps is basically a package that breaks out the previous heat mapping functionality from Explainable AI. As before, you have some utilities. You can have default heat mapping settings based on your method that you use to generate the explanation. You can override all of these presets by specifying custom color schemes or methods to reduce color channels to a single scalar number that can then be mapped to a color scheme. I've also previously shown a new function called heatmap overlay in the context of GradCam, which basically overlays your heat map over the original image, which can be nice to sort of understand the decision as a human. And then this was highly requested at the last sort of JuliaCon 2022 is text-heatmaps.jl. So with new language models on the rise, I think it's important to be able to visualize classifications on text as well. And basically, you can just assign numbers to each of the words, or tokens. You could break this up however you want, and then we can just visualize this for you. This works in HTML, so in Pluto notebooks. Here in Quarto, it also prints the words in color for you in the REPL, so that can be very nice if you prefer an interactive workflow. All right. Yeah. Finally, the interface. It's quite simple. So the only thing you need to do is that your method has to subtype this abstract XAI method type. It has to implement an analyze function, and it has to return an explanation, which once again is a very generic parametric struct that can contain almost anything. And the benefits you get from this is that you can automatically compute heat maps using vision heat maps and text heat maps. You can compose it with other methods that we have, such as input augmentations from ExplainableAI.jl. It's fully dependency-free, which is very nice. It's super lightweight, and it makes it a good candidate for package extensions. So even if you don't plan on making your package part of this whole Julia XAI ecosystem, you can just put a package extension in there on XAI base and offer a way for your package to be used within our ecosystem. And yeah, that's more or less it. Do you have any questions?
All right. Thank you for the great talk. We have time for probably one question and one person with their hand up. So,
okay, that's two questions in one. Do you plan to include shap.jl? And second is, does that work with regressors as well?
So for now, we're focusing on classifiers. There are some extensions of these methods for regression models, but currently we don't implement them yet. I would be open to sort of include this in the ecosystem. On the question of SHAP, that's an open issue. I know there's already at least 2 packages implementing Shapley values. I think they're mostly focused on tabular data. In general, Shapley values are something that scales pretty badly for vision models, for example, because you have such high-dimensional data. But you could extend this on, I don't know, superpixels or similar things. That is absolutely something I would love to see happen. Yeah. Thank you for the question.
all right. Thank you, Adrian.